Okay, so we got another example here. We're going to go ahead and multiply these two matrices. Before we do that, I'm going to go ahead and write down the dimensions row by column. So this guy is a 1 by 2, and we're going to multiply it with a 2 by 1. So the inner dimensions match. So yes, we can multiply them, and my outer dimensions are going to create my new matrix. So it's going to be a 1 by 1. We're just going to have one spot right there. So, and the way this works is because we take rows and we multiply it by columns. So if there's only one row and one column, there's only these things that we can multiply together. There's nothing else. So to get this resulting spot, right, I'm going to take 12 times 10 plus 3 times negative 5, and so that's 120 minus 15, so that would give me what's left over is 105. So what some people sometimes get confused with is like, how do we go from something with, you know, 1 or 2 rows to something with just one number in it, and that's quite all right. There's nothing wrong with that. The way that the operation works, we're getting just one piece left over. Okay, so now with this, we're working with another example here, and we're still doing matrix multiplication, but now we have variables to solve for. So I don't necessarily have to go through the whole process, and we should know that the idea of corresponding elements are going to equal a certain spot. So for example, if I was to get this spot right here, this is row 1, column 1. So I would take row 1, column 1, and I would go ahead and that would equal this spot. So knowing that, I could just take row 1 and column 1, multiply it together, and set it equal to 14. So that's going to allow me to solve for y. That same rationale is I need x, right? So depending on what's given to me, I can just go through this and say, okay, to find x, we'll do that in blue. I mean, I could use anything I want. I'm just going to use this. I'm going to use this. So row 2, column 2. So this guy is row 2, column 2. And just by coincidence, they're both 14. But what's highlighted in red and what's highlighted in blue are the things that I need to put together to solve for the respective variables. So if I was going to solve for y, so this is the work for y, I'm going to get 3 times 2y plus negative 1 times 4 is equal to 14. Okay? So that's 6y minus 4 is equal to 14. 6y is equal to 18. And so y is equal to 18 over 6, which is the same as 3. Okay, so 6 goes into 18 3 times. So now I'm going to go ahead and work with the x, the blue. So that means I take my 2 times my negative 2. So for x, it's going to be 2 times negative 2 plus negative 6 times x. That's also going to equal 14. I could have chosen pretty much any process. The only thing I wouldn't recommend is having the 2y and the x together somehow, and that's not going to happen with both of the variables being in the second matrix. So negative 4 minus 6x is equal to 14, so negative 6x is equal to 18, and so x, dividing out the negative 6, is equal to negative 3. And you can plug those back in and work through it and make sure it works. And so that's our second example, matrix multiplication, but solving for a variable.